Okay, so basic probability, just a couple of rewinds here on some things. It's going to be our successes, what we want to happen. Over our total number of outcomes. Okay, so what I want to happen over anything that could possibly happen with that. And I know I use as the example, of course, I got to go back to the thing that I need a card for, but so goes life. So, deck of cards, my probability of getting red, since there's 13 hearts and 13 diamonds, I'd add those up. That's my successes. And then the total number of cards in the deck would be my total outcomes. So you're like, yeah, this was the part on the quiz that I actually did a good job on, okay? And again, I just have to pay attention to what it is I'm trying to find. Okay, probability of finding a heart. Okay, there's 13 of those. Again, out of the grand total of 52, and math enter is a good idea. I'll be honest, if you put 13 out of 52 and that was the question on the final, but it's going to be multiple choice, so you won't even see that as an option. But don't think you've done it wrong. Just do math enter to always make sure that you've got something going. But it can get a little more specific, and that's where you need to be careful. Red 7. Okay? There's 4 7s in the deck, but only 2 of them are red. So I have to really watch what it is that I'm being asked to find. When I do something like that, and I can even throw a weird one in on you, a black heart, you're like, wait a minute. Hearts are red. Yeah, so there's no black ones. You can have a probability of 0 if something never could happen. So just something to be on the lookout for. Okay? But it won't always be a single event like that, so they'll be compound. Okay? When they're compound events, we multiply them together when we get an and. If you do this and something else. So if I roll a dice, flip a coin, what's the probability that I roll a 5, 1 out of 6, because there's only one 5 on a die, then flip a tail, in which there's 1 chance out of 2. And then just multiply them together. But again, that's when there's 2 events happening with each other. Okay? They're independent, they don't affect each other, but they still are both going to occur. Okay, same thing here. If I roll a pair of dice, what's the probability to roll a pair of 3s? One die, what I get, doesn't affect the other one. So still, what's my chances of getting a 3 on a die? 1 in 6. What's my chance of a 3 coming up on the other one? 1 in 6. And we get 1 out of 36. Okay. So as I keep moving along here, okay, dependent events are multiple events that affect each other. This is where that given part comes in that we've talked about before. So when's a situation like that occur? Okay, if I got a deck of cards, what's the probability that I'll get 2 aces in a row without replacement? Because if I pull an ace out, okay, that's out of the deck now. So there were 4 aces to start with, and there's 52 cards. But once I pull that ace out and I have it in my hand, how many aces are left in the deck? 3. How many cards are left in the deck? 51. And I have to pay attention to that. And then I would multiply across. I'm not good enough to do that today. Well, sometimes I would be. And if I do a math enter, which I actually have done in advance. Okay, so you could, theoretically, if you were doing this actually with a deck of cards, you'd have to try this experiment like 221 times before you'd actually get that pair of aces. So yeah, that's not very good odds. Okay, so then secondly, we've got 30 students in class, 17 are boys and 13 are girls. We need to select a president and a vice president. What's the probability of us having a female president and a female vice president? So again, success, female, over total, 30. Okay, that would be our president option, 13 out of the 30. So we've chosen our president, and it's a female, so she's standing over here. Now I've only got 12 females left to choose from, because again, this isn't like a communism where she could be the president and the vice president. At least I hope not. And then out of 29 that are left. So I'd multiply across. And again, I always just want to reduce down my fraction. And work it that way. So again, that's kind of how dependent is different from independent. Okay, that I'm going to still multiply them together, but that bottom value is going to change most of the time with those. Okay, so then, when I get up to 3, this is where it changes up again a little bit. We've been talking about and this happening. Now we're going to start seeing or. When I see the word or means I'm going to be adding the probabilities together. You're like, okay, so I can see how I'd add those, but what's this about then? What's this minus part? If there's any sort of an overlap or a repeat within the first two probabilities, I've got to take that part out. So here's what I mean by that. Back to our deck of cards again. What's the probability of pulling a red card? Okay, let's do that first. A red card, we've said, is 26 out of 52, because half my cards are red. Or, which I know is plus, a 2, of which there's 4 of those. So you're like, why can't I just add those together and say that's my answer? Here's my problem. Okay, so here's my red. What's that?
You said the 4's already in the 26, right?
Right, I've got a couple of these because if there are any red 2s in the deck that are both, I'd count them twice, and there are. There's 2 red 2s. So those 2 that would overlap in these 2 things, I got to take out, because otherwise I'm giving myself a better chance than I really have. And then I can reduce my fraction. So whenever you do the ors, always take a second chance to look and say, okay, is there something they have in common? And if there is, I've got to take that part back out. And then for my second example right below there, okay, if I'm rolling a die, what's the probability of rolling a 6, 1 out of 6, or a 3, which is also 1 out of 6, but there's no overlap there. If you get a 6, you're not getting a 3. If you get a 3, you're not getting a 6. So I just add those 2 up, and I'm done. So there won't be a minus part every time. You just got to kind of play it by ear and see if those repeat possibilities are in there. And then finally, okay, we get back into our givens again. Now we were good at this when we were working on Unit 7. So again, conditional, probability of one event happening given another has. So when I go looking through these, I just noticed, that should say B. Okay. So here, okay, probability of a production worker. Notice there's no given here. Just a production worker. So I go, where's the production workers? Okay. So there's 92 of them total. And my total is 140. And again, I've just got to reduce that down. And that's it. Okay, so I don't want to overthink these, but I do need to read in to see what's going on. Okay, I look at the next one. Independent or a production worker. Okay, so independent, total, there's 17. 140 total people, that's where the 140 is coming from. It's just my grand total over here. Production workers, there's 92 of them. But before you add those and circle it, think about it for a second. Are there any independent production workers where the 2 things are together? Yeah, there's 8 of them. So I've got to take that 8 out. Otherwise, I'm again getting too large of a probability. So wherever that overlap may be, that's where I'm going to take that back out. So again, sometimes it's just one little word here or there that kind of changes things. But now I finally get to the givens here. So probability of an executive given it's a Republican. Remember how this works. You're going to take the two things combined, so the Republican executives, and you divide by whatever is after the given. So, Republican executive. Okay, there's 34 of those. Yep, and over the total number of Republicans, which is 55. And that's it. That one actually didn't reduce anymore, so that's why that's it so quick. But again, it's the little words, or, and, given, that kind of determine how we're going to do this. And then the last one more given. Independent given a production worker. So I'm looking for independent production workers, the two things together, over production workers, whatever's after given. So independent production workers, I got 8 of them. Straight up production workers, I got 92 of those. And if I do some math enter this time, I can reduce that one down some more. So, okay. So now between the Unit 4, Unit 5, Unit 6, and Unit 7 refreshers, you've seen examples of everything that is going to be on the final. Again, we're going to do one more different final review on Monday. But for now, kind of keep working with these. Keep the refreshers. Keep these note sheets handy, because when we get to that last one, they could come in kind of useful. As always, there's a key up front if you want to be able to check things over, and we're done.